Good morning. Right, today we're going to talk about the exercises I gave you, and I'm going to ask you questions because I know everybody did the work. Is that right? Yes. I can see in your eyes. I know where to ask and who to ask. All right. All right, the first one, the first circuit there. What should the output look like? All right, where will I start? I think that lady got the answer. Huh? The output, what does the output look like? V out. All right, she's going to help us. You think? Is what? Zero. Yeah, that's quite a fast answer. Zero. What are you saying? Past the 15. What are you saying? Same as that. What are you saying?
It's the inverse of V.
Inverted what?
Inverted sine signal.
Inverted sine signal. Think it's going to be a square wave. All right. It seems to me you did your work very nicely. A lot of wrong answers. It's going to be a square wave. Why a square wave? Because there's no feedback. That means it will be a square wave. And what can I say about the phase shift? 180 degrees phase shift. That means the output will look like this. When I go positive, input goes positive with respect to my reference. My reference is 0. When the input goes positive, the output will go negative. Right, to what amount? To minus 15 volts. All right. And it will stay negative for that duration of time. Stay negative. All right. At that point, what happens? My input goes negative with respect to my reference. When it goes negative, it will shoot up positive to plus 15 and stay plus 15 for that duration of time. Right, there's the correct output. You with me? Does everybody agree? There's no feedback. That means the gain is open loop gain, and that's why it will follow. It will basically give me a square wave out. All right. All right, number 2. What can we say about number 2? What is the output voltage? Let me start asking. And we're going to write the answers there. All right, I got an answer here. I'm going to write them down here. Minus 5 volts. What are you saying? Huh? Plus 5. All right, I got another answer of plus 5 volts. Zero. All right, I got an answer of 0 volts. What are you saying? Do you have an answer for me? Do you have an answer for me?
I thought it was +5.
All right, we got a positive 5. Nothing. You're not sure? That's also an answer. What's your answer? 5. All right, we got plus 5. 0. Well, it seems 0 is winning. Huh? Minus 10. All right, we don't have a minus 10. Let's write it down. Minus 10. Huh? You're not sure? All right, we got a few not sures. We got from minus 5, plus 5, 0, and minus 10. The largest amount is 0 volts. Let's go and work it out. First of all, what is my reference here? 5. What will an op-amp try to make the voltage there? 0. What must it make the difference? The difference is 0. What should the voltage be here? It should be plus 5 there. All right. Now, what must we do? We must go and calculate the current. How does current flow? Current flow from positive to negative. That means there's a current that's going to flow in that direction. What is the voltage difference across that 10K? It's 5 volts. Because I got plus 5 and I got plus 10, it's a difference of 5 volts. That means if I work out the current, it's going to be equal to 5 volts divided by 10K will give me what? 0.5 milliamp flowing in that direction. That means the op-amp will adjust its output in a negative direction to get that current to flow. It will take it negative. That means this current here that will flow there should also be 0.5 milliamp. If the op-amp is not being saturated, it should be exactly the same as that current. You with me? What will the volt drop be across the 10K? It will be positive there, it will be negative there. That means we will have a 5 volt drop across there. Now what must my output be to give me a 5 volt drop? That means the output must be negative than 5 volts. What is the correct answer? Now let's go and look at the wrong answers. Minus 5 and plus 5 give me what voltage difference? 10. 10 volts divided by 10K will give me what? 1 milliamp. That means this is wrong. Plus 5 and plus 5, what's the voltage difference? 0. What is the current? 0. Wrong. Let's go and have a look at minus 10. I got plus 5 and minus 10. What is the voltage difference? What's the voltage difference? 15. 15 will give me 1.5 milliamps. Wrong. Now let's go and have a look at 0 volts. I got plus 5 and I got 0. What's the voltage difference? The voltage difference is 5. What is the current? 0.5 milliamps. Is the current flowing in the right direction? Yes, the current is flowing in the right direction. What is the correct answer? 0. What must you satisfy? Listen to me. First of all, if there's feedback, the op-amp will make this difference 0. First thing. This current and that current should be exactly the same. They should flow in the same direction. If you satisfy that, you will always have the correct answer. You with me? You listen. Must I repeat? I repeat slowly. What I normally will do, first I check this feedback, all right? The op-amp will adjust its output in such a way to make this voltage difference equal to what? 0. That means if there's plus 5 there, the voltage there should also be plus 5. All right, first one. Second one, I will calculate the current. And I will check in which direction the current will flow. The current will flow in that direction. The voltage difference here, I got plus 5 and a plus 10. The difference is 5 volts, all right? And then I work out the current and I get it at 0.5 milliamps. But now, we know the feedback current must be equal to my input current, all right? How do we get the feedback current? The op-amp, due to the supply, will take the output negative, all right? To what value? It will take it negative so that I get a 5 volt drop across here and I got a 0.5 milliamp flowing. If I satisfy that, I will have the correct answer. That means no formula. You normally like formulas. Yeah, you should know what's going on. If you don't know what's going on, you won't be able to give me the correct answer. You with me? Yes, sir. All right. Let's do some other ones. Check. Ons maak 'n bietjie soontoe. All right, let's have a look at number 3. Now I'm going to again ask some questions. Number 3, what is the output voltage? Let's start right here in the beginning, in front. What is the output voltage? Huh? What?
Minus 4 volts.
Minus 4 volts. All right, we got an answer. Let's write them down. All right, minus 4 volts. What's your answer?
Minus 6.
Minus 6. Oh. Minus 6 volts. What are you saying? No answer. What are you saying? No answer. What are you saying? No answer. What are you saying? What are you saying? Huh?
Minus
106.
6.
Minus 6. All right, we got a minus 6. Huh? Positive 10. Positive. All right, 10 volts. Positive 10 and 10 volts, same thing. All right, plus 10 volt. Negative. All right, we got a minus 30. Minus 44. Oof.
Number 3.
Ah, sorry, it's number 3. I will just write the wrong place. Huh? Plus 2,6. All right, let's write them here. I'll write them there as minus 4 volts, minus 6 volts, plus 10 volts, minus 30 volts, minus 44 volts. You see minus 2? Plus 2,6. Huh? Plus 3. Oh. Klabu? What are you saying? What? You don't know, right. Now, the only thing I want to point out, look at all the different answers for one circuit. I think the op-amp is more clever than you. He will have the correct answer. You will have all the wrong answers. You see what's going to happen in the test. See what's going to happen in the test, all right? All right, let's go slowly. How are we going to do it? First of all, what's the first thing you think you're going to determine? My reference voltage. I will determine what is the reference voltage, the voltage at that point. Now I make it, how many volts?
2 volts.
All right, it's 2 volts. I make it easy, 3 and 2 and it's 5 volts. That means here it's going to be plus 2 volts. You agree? Yes. That means the op-amp want to make the voltage difference 0. That means the voltage here should also be plus 2 volts. Everybody with me? What is the voltage difference across the 10K? There's 4 volts across it because, in which direction will the current flow? The current will flow in that direction. You agree?
Yes.
How does current flow? Yeah, now why do you want to flow it from negative to positive, eh? Plus 2 is more positive than minus 2. You agree? All right. All right, 4 volts divided by 10K will give me 0,4 milliamps. Everybody agree? That means my feedback current must flow in that direction, flowing in the same direction It should also be 0,4 milliamp. Everybody with me? All right, if I take 0.4 milliamps times a 20K, it will give me how many volts? 8 volts. That means it's going to be here, positive, negative 8 volts. All right. Now, remember, this point is not at 0. That point is at 2 volts. You agree? All right, it's at 2 volts. That means I must have an 8-volt difference. That means my output must be 8 volts higher than 2. And that should be plus 10. Only one correct answer in the whole class. You agree? Who had a plus 10? Oh. Yes. Yeah, how do I find 4 volts? All right, let me show you. Have a look here. If I draw a line like that, let's say there is 0. 0 volts, all right? There, let's say it's plus 2 volts. There is minus 2 volts. What is the difference? S3, you don't know that, my friend. You see what you want to do? You want to say plus 2 and plus minus 2. What will that give me? That will give me 0. If I add 2 and minus 2, if I add them together, what will it give me? 0. But we look at if you want to calculate current and anything, you need the voltage difference, right? Same thing, if I got plus 15 and minus 15, what's the difference? It's 30 volts. It's not 0, it's 30 volts, all right? Everybody with me? You happy? Yes. Very simple, eh? And now you must remember, I can put a dart in the feedback loop, I can do anything. Hey, there's a lot of questions I can ask. Oh, you won't know what I'm going to ask. You will find out when you write the test. All right? All right, let's have a look at the number 4. All right, answer on number 4. Anybody, give me one answer. Minus 50. All right, let's try. I'm not going to ask everybody, but let's say your answer is minus 50 volt. Minus 50 volts. Let's check if it's correct. First of all, what is my reference? My reference is 0. All right. That means the op-amp want to take this point also to 0 volts. You with me? That means here I will have a current flow in that direction. What will that current be? 5 volts divided by 10K will give me 0,5 milliamps. All right. Everybody with me? This current is going to flow in that direction. 2 volts difference, and 2 volts divided by 2K will give me 1 milliamp. That means this current is going to be 1 milliamp flowing in that direction. The third one, I got 3 volts, and I got 0 volts at my summing point. That means this current is going to flow in that direction. 3 volts divided by 1K will give me 3 milliamps. You agree? All right. The 3 and the 1 milliamp will subtract from one another. That means it will give me 2 milliamps. That will give me a total current of 2.5 milliamps. Flowing in which direction? That current will flow in that direction. That will be 2.5 milliamps. 2.5 milliamps times 20K, that means it will be positive here, it will be negative there. That'll give me how many volts? 50 volts. 2.5 milliamps times 20k will give me 50 volts. That means the output will be negative because my reference is 0. That means the correct answer is minus 50 volts. Hey, it's simple, eh? Easy. Easy as pie. That's more on your standard, number 5. Let's have a look at number 5. Well, let's ask somebody else. Our clever friend here in front. What's the output voltage?
I made a mistake. I forgot it's a negative 5. But the wrong answer I got is minus 40.5.
Minus 40.5. 48.5. What? Minus 39.5 ohms. That doesn't look like a volt. Oh, all right, now it's a volt, all right. All right, let's have a look. Let's have a look. What's going to happen here? First of all, my reference is what? Minus 5. Minus 5, that means the op-amp will try to make this voltage here minus 5 volts. All right. All right, I'm just going to put the currents here on the side to make it easier. There's not so much space there. The first one, I got plus 5 and minus 5. What's the difference? 10. 10 divided by 10k will give me 1 milliamp. That means that the first one will give me a current flowing in that direction of 1 milliamp. You with me? The second one, the current's also going to flow inwards because there I got minus 5, there I got 1 volt. The voltage difference is 6 volts. That's also going to flow inwards. I got 6 volts there. 6 volts divided by 6 volts divided by 5k will give me what? 1.2 milliamps. That means that current's going to be equal to 1,2 milliamp flowing inwards. Here I got 2 volts and 5 volts. That will give me 3 volts voltage difference because it's minus 2 and minus 5 is a 3 volt voltage difference. The current will also flow inwards, and that will be 1 milliamp. You agree? Yes. All right, then the last one, I got 5 volts and I got 0 volts. That means the difference is 5 volts. The current's also going to flow inwards from 0 to minus 5. Current's going to flow inwards, and that will give me what? 1, 25 volts. All right. All the currents flowing inwards. All right. That means that I must get the resultant current, and that will give me 1, 2, 3, 4 milliamps. It will give me 4,45 milliamps. That means the total current is going to flow like that. And that's going to be 4,45 milliamp. Everybody with me? You agree? All right, that means if I take 4,45 milliamps multiply by 10k, that means this side will be positive, that side will be negative. That will give me 44,5 volts across the 10k. 44,5 volts across the 10k. All right, what will my output be? That means I must be more negative than 5 volts. That means the correct answer will be minus 49,5 volts. Who had the correct answer? Only one. Man, 48.5 is wrong. There's nothing like that. It's not like politics. The correct answer is the correct answer. In engineering, it's a correct answer or wrong answer. Not like politics, approximately and...
The mistake I did was forgot to make it negative. I forgot the variables negative.
If you forgot the negative, you forgot, then it's wrong. Not approximately. That means if the answer is 40, let's say you give me the answer of plus 49.5. It's wrong. The only correct answer there is minus 49.5. All right. All right, let's have a look at this circuit here. Number 6. My input voltage or my reference here is minus 10. All right, that means the op amp will adjust its output in such a way to make the voltage there also minus 10 volts. You with me? All right, how's the current going to flow? This current is going to flow from positive to negative. 0 is more positive than a minus voltage. Flowing that direction, 1 milliamp. Feedback current flowing like that, 1 milliamp. Now 1 milliamp times 20K will give me how many volts? 20 volts. That means positive, negative, there will be 20 volts across that 20K. That means now this current, that's also going to be positive, positive, negative. What's the correct answer? Minus 30 volts. All right. What circuit is this? That is actually a non-inverting amplifier. I just redraw it a little bit different than the one in the book, but that is a non-inverting amplifier. How do we calculate the gain of a non-inverting amplifier? It's RF over Rin plus 1. All right, or 1 plus RF divided by Rin. And now if you work that out, 20K divided by 10K will give me 2. 2 plus 1 is 3. 3 times minus 10 will give me minus 30. Any questions? Let's move on. All right, let's look at the Right, let's look at number 7. Number 7, I put a step function in. That's a step function. And I want the output. Now I ask you, V out at t is equal to 0. The output will do the following. If I can draw it in here, the output will do the following. The output, when I go positive, it will integrate negative. That means the output will do something like that. Till it reach, let's say, minus 15 volts. That means at t is equal to 0, what is the output voltage? The output voltage is 0. That means here the answer is 0 volts. All right. V out at t is equal to infinite. That will be minus 15 volts. All right. Because that thing will integrate to that. If we look at the next circuit, no, it's black, then it's red. I don't know. Let's put that one back. Right, forget about it. Let's try to. That pen doesn't want to work nicely. Let's put a reference voltage in there. Let's make this 1 microfarad, doesn't matter. Let's make this a 10 kilo ohm. Right, there's a circuit. Now that's a differentiator. What will the output do? If I apply a step function to that, the output will look like this. It will shoot down to, let's say, minus 15 volts, and then the capacitor will start charging positive there, negative there. That's what the output will look like. Now I ask you first, V out at t is equal to 0, that answer should be minus 15 volts. Then V out at t is equal to infinite, that will be 0 volts. All right. All right, I got some other circuits. I don't think I got them here now, but I can ask you a lot of different questions on this work. All right, I think that's all for today. I will get you some other circuits to help you a little bit. I got a lot of different circuits of those. We can put anything in the feedback circuit. We can put a Zener out in the feedback circuit. That means we can give you a lot of different things to do.